For decades, NATO has operated under one central assumption: control of the skies. Western air superiority has long been the foundation of modern military operations, but in recent years, a system has emerged that challenges that assumption. Its name is the S-400 Triumf. Across Russia, production of this system has continued to expand. Defense factories are operating at a higher pace. New units are entering service. For Moscow, the S-400 is more than an air defense platform. It represents technological independence and a tool for building wide defensive zones that are difficult for adversaries to penetrate. Today, we take a closer look. How the system works, why many analysts consider it one of the most influential air defense systems in the world, and how it is beginning to reshape strategic calculations across Eastern Europe. Behind every advanced weapon system lies an industrial foundation. Russia has retained a large defense manufacturing network inherited from the Soviet era. One of the key companies behind the S-400 is Almaz-Antey. Multiple facilities contribute to the production chain. Radar systems, launcher vehicles, and long-range interceptor missiles. One of the primary missiles used by the system is the 4ON-6 missile. This interceptor is reported to have a theoretical range of up to 400 kilometers. In operational planning, the intended targets are not limited to fighter aircraft. Support aircraft are equally important. For example, airborne early warning platforms such as the Boeing E-3 Sentry. Aircraft like these play a critical role in coordinating NATO air operations. Because of that, long-range air defense systems can potentially force them to operate farther from contested airspace, and that distance may influence the effectiveness of aerial coordination. One of the most debated questions in modern warfare is simple. Can radar detect stealth aircraft? Fifth-generation jets, such as the F-35 Lightning II, are designed to reduce radar reflections. But Russia has pursued a different detection strategy. Instead of relying on a single radar band, they use multi-frequency radar networks. One example is the Nebo-M. This system operates across multiple frequency ranges. High-frequency radar provides precision tracking. Lower frequency radar can detect disturbances caused by large objects in the air. In practice, these systems often operate as part of a network. One radar detects a potential target. Another radar refines the track. Command systems then guide interceptor missiles toward the target. Some analysts believe this layered approach may improve detection probabilities against stealth aircraft, although its real-world effectiveness remains widely debated among military experts. Technology is only part of the picture. Strategy is equally important. Russia has invested heavily in a concept known as A2/AD, anti-access and area denial. The idea is straightforward: create zones where operating aircraft becomes extremely risky for an opponent. Systems like the S-400 form the backbone of these defensive networks. Several locations are particularly strategic. One of them is Kaliningrad. Positioned between Poland and Lithuania, this region provides coverage across parts of the Baltic area. Similar defensive frameworks are also deployed in other locations, for example, around Crimea. By integrating long-range radar with missile systems, Russia aims to create overlapping layers of air defense. This forces military planners within NATO to carefully reassess the risks of operating near these areas. Modern air campaigns often begin with one critical mission: SEAD, suppression of enemy air defenses. The objective is to disable radar systems and surface-to-air missile networks. One of the most widely used weapons for this role is the AGM-88 HARM. These missiles are designed to track radar emissions. However, modern air defense systems rarely operate in isolation. S-400 batteries are often supported by shorter-range systems. For example, the Panzer S-1. These platforms protect key radar assets from drones, cruise missiles, and other close-range threats. Layered defense networks like this add complexity to CAD operations, and they demonstrate how modern air warfare increasingly depends on coordination, electronic warfare, and advanced technology. Military technology is constantly evolving. Every new system introduces new challenges. The S-400 is one example of how advanced air defense can influence global strategy. For Russia, it represents a tool for protecting national airspace. For NATO, it is a factor that must be considered in future planning. Whether systems like this will fundamentally change the balance of air power remains an open debate among defense analysts. But one thing is clear: competition in the skies is far from over. If you enjoy in-depth analysis of military technology and geopolitics, consider subscribing to the channel. And we will see you in the next episode. Military technology is constantly evolving. Every new system introduces new challenges. The S-400 is one example of how advanced air defense can influence global strategy. For Russia, it represents a tool for protecting national airspace. For NATO, it is a factor that must be considered in future planning. Whether systems like this will fundamentally change the balance of air power remains an open debate among defense analysts. But one thing is clear: competition in the skies is far from over. If you enjoy in-depth analysis of military technology and geopolitics, consider subscribing to the channel. And we will see you in the next episode.